Alright, in this lesson we'll be examining the notion of a picture is worth 1,000 words. One of the things that I will always recommend that you do when you get or collect data is that you take a look at it pictorially. It's a good way to just initially explore the data. The method that you use actually depends on the type of data that you have. So let's look at some different types. One of them is a pie chart. A pie chart is a circle that is dissected from the center. Each slice represents, in this case, the number in a category. So this is the categories of year in school at Texas A&M. Notice that the whole circle does represent all of the people, in this case, within the population. The next pie chart doesn't represent the actual numbers, but percentages. So here each slice represents the percentage in each category. It probably goes without saying, but the largest slice has the largest number or the largest percent. These pie charts were actually made in a statistical program called SPSS. We'll be talking about that SPSS statistical program. You'll be looking at lots of output throughout the semester. How about some comic relief? Why'd the Aggie get fired from the M&M factory? He kept throwing away the W's. Speaking of M&Ms, I would highly recommend going out and buying several packages of M&Ms to get you through this term. And as it actually turns out, we're going to be doing some exercises using M&Ms. So next time you're at your grocery store, go ahead and buy 5 or 6 packages, some of them to snack on, some of them to use for our little projects. The next type of picture is a bar graph. The bars represent the number or the percentage in a category. Again, the highest, or in this case the longest, highest if you turn it on its side, the longest bar or the highest bar represent the category with the greatest number in that category. Nextly, we'll be talking about a frequency distribution. Frequency distributions are used with interval or ratio data. There's some information here about class intervals. Class intervals are used particularly when you have very large data sets. I'll be doing a separate lecture on how to create a frequency distribution, so you can see that a little bit later. Nextly is a stem and leaf display or stem and leaf plot. For scores 0 to 100, the first digit is the stem, the second digit is the leaf. Again, there'll be a separate lecture about how to create this. On the next slide there is an example of a stem and leaf. So it's based on those 20 exam scores. So here's a stem and leaf based on that. So we'll be talking about that in a separate lecture. Nextly, we have a histogram. Histogram is a type of bar graph, except that the horizontal axis is a score on whatever it is that you have measured. It's not a category. So the score, for our purpose, is going to be something that is interval or ratio data. Notice the vertical axis actually does represent the frequency with which each of these scores was observed. A frequency polygon is the next type of picture. Here, the middle of each of the bars is connected by a line that really kind of smooths out the picture for you. Most frequency polygons in social sciences will look like or will follow the pattern of what's called the normal curve. We'll be using the normal curve quite a bit during the term, so you'll hear more about it and a lot about it a little bit later. Let's look at some shapes of different histograms. So the first one that we talked about already is the normal curve. In the normal curve, the mean, median, and mode are in the center. Again, lots more to come about it a little bit later. A uniform distribution is one in which each observation is observed with equal frequency. I won't see that a whole lot, but you might hear the term. The next one is bimodal. Bimodal deals with, bi means two. Bimodal means that there are two peaks in the data. So unimodal would be a normal distribution. Bimodal, it has two peaks. The next one is skewness. Skewness implies that generally that there are more scores on one end of the distribution rather than the other. They are named by their tail, the longer of the tails. So a positive skewed distribution has more lower scores and fewer higher scores, and a negative distribution has fewer low scores and more higher scores. So stop and think about it. Which of these is what we want to see on our tests? Positively skewed or negatively skewed? Hopefully you said negatively skewed, even though we don't like to say negative about anything, but negatively skewed implies that more people scored at the higher end of the distribution of scores. The last type of histogram deals with kurtosis. There's two types, platykurtic and leptokurtic. Platykurtic is one that is flatter. Typically you would observe greater variability within that distribution. Leptokurtic is one that is more peaked, so it's very tall and skinny, and you would expect to actually observe less variability within that set of data, within a leptokurtic distribution of scores. The next slide depicts a box plot, and I'm going to be using actually some terms here, and you'll be reading about some terms here that we actually have not defined yet, so you might want to come back and take a look at this once we've actually defined the term. This again was made in a program called SPSS. We'll be using that quite a bit again. Notice too, before we start talking about what everything represents, that on the vertical axis these are the actual observed scores. All right, so let's talk about the box. The box represents the interquartile range. So the bottom score, or the bottom of the box, represents the score at the 25th percentile. The top of the box represents the score at the 75th percentile. So this box represents the middle 50% of the scores. The dark line in the middle represents the median, which is the 50th percentile, and that implies that there are 50% of the scores above the median and 50% of the scores below the median. The next lines are the whiskers. I'm going to actually come back and talk about the whiskers later, because I'm going to jump down and talk about this guy down here. SPSS identifies what are called outliers. Outliers are scores that kind of are not the same as the rest of the scores. So that 9 doesn't mean that that someone scored a 9. That 9 represents the fact that this is the 9th person that actually put into SPSS. So that was actually a score, I believe, of 52. So 52 is so different from the rest of the scores that SPSS actually identified it as an outlier. The whiskers, let's jump back to that. The whiskers then represent the range of scores above the 75th percentile, the range of scores below the 25th percentile, and the whiskers do not include any scores that are considered outliers. So the 75th and the 25th and the 75th percentile, so this is the middle 50% of the scores, the median, and then the whiskers extend from the box out to the range of scores that are not considered outliers, and then outliers are represented by a single dot, and the number doesn't represent the actual score. It represents the number of which person actually scored, in this case the 52. So when I put this data into SPSS, it was the 9th person. Before we leave this, I want you to pay particular attention when you go read the section on the graphical display in Coolidge's books, page 57. To pay particular attention to how graphs can be very deceiving, particularly when there are small differences in the data. So maybe you're plotting some means and there's small differences between the means, but those small differences can be made to look like large differences. So pay close attention to that when you go read the chapter on the graphical display of data.